Guys, welcome or welcome back to Chalang to MBBS. And today we are going to start a new topic, which is atomic structure. Very important and quick revision of all the important points. Okay, so let's start with nodes, radial node, to which the formula is n minus l minus 1. This node basically lies within the orbital, right? And what do you mean by angular node? Angular node is just L, nothing else, because this is an angle. Angle basically lies between two orbitals. You can remember it like that, okay? And next, moving on, how do we find the total node? Add these two nodes. Radial node plus angular node gives you total node. So n minus 1 minus n minus l minus 1 plus l. This plus l and minus l cancels out to give you total nodes. The formula comes out to be n minus 1, right? Now next we move on to Schrödinger wave equation, which is the representation of n, l and m. This is actually the representation. It is basically asked in a lot of question MCQ type of forms, right? In this Schrödinger wave equation, there is no representation or the talk about the spin quantum number. Yes, next we move on to shell. Shell is K, L, M, N is a shell, right, everybody? And what do you mean by subshell? Subshell is S, P, D and F, right? After subshell we get the orbital. Orbital indirectly means a box, which is in Hindi called as dabba, right, everybody? Let's take an example. For suppose L is equals to 0. L0, here you can see the values of L for S, P, D, F subshell. For S the value is 0, for P it's 1, D is 2, F is 3, right? So if for L is 0, L0 means the subshell which we are talking about, that is S. That means M is 0. M0 means only one value, means one dabba, one box we are talking about. L is 1. L is 1. Here we are. L is 1. We are talking about the P subshell. P subshell, the value of M basically lies between minus L to 0 to plus L, right? So here we are having three values, so we are going to make three boxes representing Px, Py and Pz. So here indirectly, this is not the proper representation, but we can say that the value of Pz is 0, Px and Py can have a value of plus 1 and minus 1. Moving on to very important N, L and M, a very quick revision of this. N represents shell or the orbit. It can be any integer 1, 2, 3, 4 and etc. According to NCERT, N represents size and energy of the shell, right? Moving on to L. L is also known as azimuthal quantum number. It is also known as the orbital angular momentum, subsidiary quantum number. But here, the value of L depends on M. The value of M depends on L, right? We can say that. Okay. Moving on to, so how does it depend? Let's see. For example, the value of L ranges from 0 to n minus 1. You have to remember these short points also. For example, if n is given as 1, that means there is one shell, and one shell the value is 1 minus 1, that means 0. L is 0 for S subshell. Okay, moving on to n is equal to 2. What do you mean by n2? N2 means the value of L will be 0 to n minus 1. What is n here? N we can keep as 2. So 0 and 1. So means two values are there, right? And again, it's very important because L is also known as orbital angular momentum. Orbital angular momentum means it will have MVR is equals to under root of L plus 1. Remember, this is 1. I did this question wrong in my mock test also. Then moving on to M, which represents the orientation of the electron cloud. The value of M again, which I told you, it depends on L. So it will range from minus L to plus L. For example, if L is 0, okay, Moving on to m will be 0. If L is 1, it will have values of -1, 0, 2, +1. Moving on to Aufbau principle. Aufbau principle, we will discuss it later also detailedly, but here I am only discussing about the energy levels. Okay, so Aufbau only and only talks about the energy of the subshell, which is dependent by the formula n plus L rule. So what is n? It is this n, okay, which is the principal quantum number, and L is your subsidiary, or you can say azimuthal quantum number. Moving on, how do we decide the energy which is dependent on n plus L rule? For example, 1s. Okay, so what is n here? N represents just the number beside the subshell, which is 1. So L here for S, I have already told you, for S the L value is 0. So 1 for this, and the value of L for S subshell is 0. That means 1 plus 0 gives out 1. For 2, 2 plus 0 is 2 here. 2p, 2 for P, the value of subshell is 1, so 3. Like this you will do for entire thing. And here many questions are being asked to find the order of increasing energy, and you will get MCQ for must from this topic. So yes, that's arranged in a particular order. So 1 is less than 2, moving on to 3, and then 4 and 5. But here comes the confusion between 3 and 3. How do we decide that 2p is greater or 3s is greater? Only and only by this part, by this number. 3 is greater than 2. That means first the electron will enter in 2p, and then it will enter in 2s. If n plus L, the value of n plus L, here the value of n plus L are same, that means what is the rule number 2? That n is directly proportional to the energy, right? Moving on to here, an important question is, for example, you're talking about n plus L is equals to 4. My value is coming. So what are the possible subshells? We always know, I had told you that n is always greater than L. L is always greater than M, and S does not depend on any of these quantum numbers. Okay? It only has a value of plus half and minus half. That's it. Right. So here the question is, n plus L value should be equal to 4. So let us assume 0, 1, 2, 3, 4, 4, 3, 2, 1. 0 and 4 not possible. Why? Because n has to be greater than L, but n is 0 and 4 is greater, right? So this is not possible. Again, 1 is less than 3, so not possible. 2 and 2, n can never be equal to L. N is always greater than L, so this is also not possible. So there are possible two subshell of 3p and 4s for the value of L to be 0. So 3p and 4s are only possible, right? Okay, so orbitals means डब्बे कितने possible है? 4 है. S का एक डब्बा, 4s का, और p के 3 डब्बे, that is px, py and pz. So if they are going to ask how many total number of electrons may be possible for the question of n plus L is equals to 4, you will have 4 orbitals are there. In each orbital we can accommodate a maximum of 2 electrons, so total there will be 8 electrons. Now again, this is a very important part which is taken from NCERT itself. The energy of the orbital in hydrogen atom. Hydrogen atom has an exception. What is there? For hydrogen atom, the n plus L rule does not follow. The energy order only and only depends on the value of n. See here, 1s and 2s, 2 is greater. Okay, then 2s is greater. Now for 2s and 2p, this does not depends on the n plus L value. So 2 are equal. The principal quantum number is equal, so the energy of these two is equal. Again come here, 3s and 3p, again the energy is equal. 3p and 3d, the energy is equal. 4s and 4p, the energy is equal. So this is a very important PYQ question. My mock exams, maybe it's a repeated question. Now we are moving on to some important tricky points which finds difficult to able to understand also. 1p, 2d, 3f orbitals are not possible. Why? So because the value of n for 1p is 1, and for L the value is 1. I have told you N and L can never be equal, so this is not possible. Moving here, the value of N for 2D is 2. L is what? Again 2. See here, for D it's 2 the value of L. So what we are going to do, again it's not possible. For 3F the N is 3 and L is also 3, again not possible. So these orbitals are not possible. Again, maximum number of electrons in an orbit or shell is 2n square. You have to learn the formula. Yes, for example, we are talking about the third orbit. What are the maximum number of electrons, he may ask? So total is 2 into the number square, and it comes out to be 18 electrons. Moving on to number of orbitals in an orbit. You have to focus on these words. Number of electrons in the orbit, the formula is 2n square. The number of orbitals means how many boxes are possible in an orbit. The answer would be given by the formula n square. So number of orbitals in the third orbit would be 3 square. That means 3s, 3p and 3d. Now, maximum number of electrons in a subshell. Subshell means he is talking about the L. The formula must include L. So the formula will be 4L plus 2, right? And number of orbitals, you know that electrons are always more than orbitals, right? So the formula also has more number. Here the maximum number of orbitals in a subshell, the formula is L. Why again here subshell? So formula should include L value. So you can see the example here also. Now, maximum electrons in an orbital. See, this is a very tricky question. I've done it wrong many times in my mock exam. And this is an orbital. Orbital means a box, a dabba. A dabba can have maximum 2 electrons with opposite spin. This is very important, which is coming here. Now, this is a very tricky question here, which was given by my sir. The value of 4 quantum numbers for the 9th electron of sodium atom. Imagine the tricky level. So sodium, the atomic number is 11. It can be categorized as 2, 8, 1, which can be filled as 1s2, 2s2, 2p6 and 3s1, right? So 1s2, 2 electrons, 2s2, 2 electrons, 2p 6 electrons and 3s 1 electron. Okay, now the counting you have to be very careful. If I talk about the 9th electron, 1 2 3 4 5 6 is this one, 7 is this one, 8 is this one, and 9th electron is this one. Please be very careful while counting the electron number. Okay, so if I'm talking about this one, so this is lying in the 2p subshell. So that means the n value will be 2. According to p, the L value will be 1. Because the value of L is this, I know the formula minus L to 0 to plus L, right? So the formula, according to the formula, my value comes out to be this. Moving on to S, because the electron is lying inverted, that means it is an opposite spin, which will have a negative value of half. That's it. We are done with this question. Moving on to a quick revision about the rules we are having. Pauli rule. No two electrons can have same set of all 4 quantum numbers. Why? We have seen here. Even if this is same for these 2 electrons, the value of spin will be opposite. If I am talking about these 2 electrons, one will be having positive half, the other will be having negative half, right? Okay. Pauli has another only 2 electrons with opposite spin which can be filled in a particular orbital. And a orbital can have a maximum of 2 electrons, I've already discussed. And Aufbau, there is a lot of confusion about Pauli and Aufbau. Pauli is a name of a scientist, but Aufbau is not a name of a scientist. It is clearly mentioned in NCERT that Aufbau means building up, banana, right? So Aufbau only and only talks about energy, which is directly proportional to the n plus L rule for all atoms except one electron species like hydrogen, where energy depends only on the value of n. Hund's rule, pairing of electron will take place according to my arrangement. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pairing will only be possible when each orbital has one electron. Now, this is very important exceptions of Aufbau rule. If you are clear here, the reason, the more detailed reason you will get in class 12th. So, the first exception comes out to be of chromium, which has an atomic number of 24, 2, 8, 12, 2. Right? So, according to what we know, what you people know, the configuration should be like this, right? 2, 2, 6, 2, 6, 4s2 and 3d4. But the configuration for this is 13, 1. Here is the change which we can see 4s1 and 5, 3d5, sorry. Why is this so? Because of stability. Why stability? Half filled, fully filled are more stable. Why? Due to symmetry and exchange energy. I hope you know this. You have read in NCERT also. It's clearly mentioned. This is 3d5. That means this is because of half filled stability. And again, another example which we can see is of copper 29, which is having the configuration of 2, 8, 17 and 2, and but it is written as 2, 8, 18, 1. It is stable. Why so? Because of fully filled configuration. You can write the same as this by changing 3d10, right everybody? So here we are, stability of subshell. How it depends? It is directly proportional to the exchange energy, and exchange energy or stability. Yes, here we are done with a very quick revision of all the important points and formulas. Hope you understood everything. So tomorrow we are going to come with a test yourself question series of this chapter. It will be very interesting. Just write the important notes, what you find it difficult, revise it often. So revision and practice is the key to ace the NEET exam. So yes, thank you all. Hope you liked it. Please subscribe, like, comment and share the video. Thank you.